Sorry about that, this video cut off real quickly, so I'm just going to make this into two separate parts here. So where I left off, I was talking about the leading coefficients here. So as n gets infinitely larger here, adding 1 to it really doesn't do anything because the number n is so large that the 1 becomes insignificant. So eventually n plus 1 over n can cancel out and equal 1, making this whole term 9, right? So we only focus on the leading coefficient when n gets really, really big. Same goes over here. We only focus on the leading coefficient as n gets really, really big because, like this one, the degree is the same on both the top and the bottom. Now, over here, when we multiply all the leading coefficients out, we get -9. Over here, we get 9, and here we get 24. So now, when we add these three things together, like we're supposed to find the exact area under the curve, we get 24 units squared. Now, the important thing to know here is that as n gets infinitely larger, we only are able to focus on the leading coefficients if the degrees are the same on both the top and the bottom. They are for this term, they are for this term, and this term is, we can ignore this term. It's always going to stay 24. Nothing is going to change with it. So here and here, we can only focus on the leading coefficients if we want to. So as n gets infinitely larger, what's on the top will eventually cancel out with what's on the bottom, except for the leading coefficient. That is the only thing that will stay constant, and that is over here, -9, over here, 9, and over here, 24. So then when we add these three things together, because n, remember, n is the number of rectangles we're using, so as that number gets infinitely large, we get closer to the exact area. So assuming we can reach infinity, which we can't, that's not possible, but assuming that we can only focus on we can say that it equals the leading coefficient, right? Here, here, and here. So then we just have to simply add those three things together to get our total area under the curve, which for this problem is 24 units squared.